Let's find extrema types. So there are 4 types of extrema broken down into 2 categories, global and local. So local extrema, just think you're a local maximum if you're taller than everything else around you. Right? So if you're the biggest function value, then you're a local maximum. We've got a max there, and we've got a max there. To be a global maximum, this is not a global maximum, even though it's local. This right there is your global maximum because it's bigger than everything. Right? And the same thing goes for minimums, just upside down. So let's look at these 4 extrema types. Let's first look at, let's do the local maximums first. So you can have several local maximums. In fact, I think we have several here. If I look at this graph, this point right there satisfies the definition of being a local maximum. That right there is taller than all of these other function values that are next to it, right? That's the biggest function value in that sort of open circle. So we've got a local maximum at the x value of -4, right? That's where the maximum occurs. The actual maximum value, what is that y value? Is about 0, right? That's on your x-axis. Okay, where else do we have a point that's taller than all of the other points around it? So not there, because it's not taller than all of these points to the left. Not there, because it's not taller than all of these points to the right. But right there, I see a hilltop. It's taller than everything else around it. So we have another one at x is equal to 1 with a local maximum value. What y value is that? Maybe, what is this? This is 1, so maybe 0.25. So we're estimating pretty roughly there. Okay, where else do we have maximums? There, there. None of these are maximums. None of these are maximums. But that point right there at the end of our interval is a function value that's taller than all of these function values. So we have another one at x is equal to 6. And it seems like the actual maximum value, maybe 2.5. All right, let's do local minimums. So I'm looking for points on my function that are smaller than everything else around it. So there I have a valley at x is equal to, let's estimate that as maybe -2.5. 1, 2, 2.5, sure. And it has a minimum value of maybe -1.5, right? So that's where the minimum occurs, and that's the value of the minimum. All right, where else do we have a point that satisfies the condition of being smaller than everything else around it? I think right there. So at x is equal to 4, with a value, what's the y value there? Maybe 0.75, sorry, -0.75. Okay, so unlike local extrema, global extrema, you can only have one of them. This is going to be unique. You're looking for one point that's bigger than everything else around you, or sorry, everything else in the domain. So even though that point right there is a local maximum, it's not the global maximum. The global maximum, you only have one. It's right there. Your function is biggest at x value of 6. So we won't give what the actual maximum value is because you know it's going to be one of these. All right, what about your global minimum? The point on your function that is smaller than everything else. So the smallest y value that we get is from that minimum there. So that was when x was equal to -2.5. Right, that's where we have the smallest part of our function, the smallest function value.